Hello, everybody. My name is Pratham Sikka, and I am a second year engineering undergrad here in India. In this video, we'll together be discussing what Apache Kafka is, why was it developed, what are the problems which database weren't able to solve, and hence we have Apache Kafka, its advantages, disadvantages, use cases, and unbiased opinion, architecture, consumer groups, and everything. We'll also be doing a hands-on, but all these things are for the upcoming videos because we don't want to overwhelm everyone in today's video. So let's get started without any further ado. What is Apache Kafka? Apache Kafka is an open source distributed streaming system used for stream processing, real time data pipelines, and data integration at scale. And Apache Kafka was developed by LinkedIn. So let us understand Kafka with a food delivery applications example. So in India, it is a very popular application called Zomato. You can compare it with Uber Eats or elsewhere, which are the global applications to order food and then it gets delivered. So once you order food, it redirects you to a module which there is the Google Map view featuring the live location of that particular location of the delivery partner. So you get the real time feed as well. Like once you order food, then you redirect to that page and that has status like your food is being cooked. The delivery partner is coming in so and so minutes to our restaurant to pick up the food, and now the food is dispatched. In so and so minutes, it'll reach your home. This is to develop an anticipation in the customer that the food is arriving in so and so minutes. Now let's understand how did they develop this from an engineering perspective. So approximately such is the wireframe of their UI which they have. So this is the Google Maps location which they most probably fetch from the map API, or maybe they must have designed it in-house, and it generally has these two things. So it fetches the current location on the map from the driver's or the delivery partner's mobile, and then it gets sent to the customer. Now the driver's mobile has they get the current location variable from the driver's mobile, and it gets updated after every second. So the location, and you get to see the real time updates, and then it sends to two places. One is the Zomato server and second is the customer. So it is to display the Zomato server, and also to the customer this location has to be sent. The location will be inserted in the database real time. Now, if we want to implement something of this sort, let's understand and ponder upon the fact that how they must have implemented this functionality from an engineering perspective. The functionality is somehow like this. So, for example, the delivery partner dispatches your food at 12 p.m. So the location will be updated every 1 second, but let's assume for simplicity's sake for every 1 minute. So 12 p.m. and then 12:01 p.m. and then 12:02 p.m. and further so forth. The location will update. Our functionality will be complete when we are able to accomplish the fact that 12, 12:01, 12:02 p.m., the real-time updates are being fetched and displayed to the customer, and they're also stored in the database. So the problem is that we will maximize and exhaust the number of operations available to the database as we are performing a lot of insert operations. So there is a probability that the database may go down, and the database going down is, you can imagine how big of a problem it is when once you are dealing with a lot of concurrent users and handling their data. So that's something we definitely don't want. We can also consider this via the example of Uber. So any application which you use to book cabs and use the same functionality. So Uber, the delivery partner fetches or picks up the customer and drops them to the destination. And meanwhile, they have to take care of all the services which they are handling. So one service will be the logic to decide the amount of fare which is calculated, and the other service is maybe some of the analytics service they have, and the third is the customer service, which is to show the customer all the metrics during the ride, and they'll have all the internal services as well. Now let's consider that worldwide there probably will be more than 100K concurrent delivery partners or drivers which Uber or Zomato or such companies must be employing. And if 100K concurrent operations per second, it's not feasible because the database will definitely collapse. At any point, this system will not scale. It is not scalable because if you exhaust the number of operations, so real time data transferring cannot happen. Databases have a lot of problems with throughput. So databases have a low throughput and Kafka has high throughput. This brings forward another question, what throughput is. So throughput is a measure of how many units of information a system can process in a given amount of time. It is applied broadly to the systems ranging from various aspects of computer and network systems to organizations. This source is TechTarget, and you can visit this link to study about this in great detail. However, in our context, throughput is the number of operations we can do per second. That defines our throughput. So ops per second is our throughput. We are essentially doing insert operations in the database. So we are inserting stuff into the database and we need to have a high throughput because we'll do approximately 100K operations per second, which is requiring a lot of throughput, which databases cannot accommodate. Hence the need for Kafka. Secondly, there is some time lag, which we need to account for. 200 milliseconds is approximately the time taken for data to be inserted to the database. This can be any hypothetical figure, and I've taken 200 milliseconds, but there is some time which is required for the data to be inserted to the database. It is not exactly 0 milliseconds lag, or it is not real time. So, this is the time taken by the data to be inserted into the database, and also then the server will also take some amount of time. That total time may account to say 800 milliseconds and approximately a second. So if the location is fetched 1 second late, that system is anyways not real time, and that is not a good engineering practice. So if there is an optimized approach, we should definitely consider that. So this thing we understood that databases have very low throughput. So if we maximize the number of operations, then databases will fail, and hence we need to use Apache Kafka. Does that mean Apache Kafka can eliminate the need for databases? No, because short answer no, long explanation that Apache Kafka has a high throughput but low storage, so data is not persistent. There is a typo, but ignore that. So Apache Kafka has a high throughput but low storage. Data does not persist. You cannot store data in Apache Kafka. Data cannot persist, and you can transfer data and it gets stored for a very short interval of time. So Apache Kafka and databases must be used together. The functionality goes hand in hand. Apache Kafka is not an alternative to databases. In databases, we can query even if we have a billions of rows. But the query indexing, yeah, you might have heard of B plus trees, B minus trees, while studying trees in data structures and algorithms in the computer science course. But that is the way by which the rows are queried in the database, but that cannot be done in Kafka. So queries take a lot of time, and hence Kafka has some downsides as well. You can easily throughput data, like insert data and pass it through, but it cannot be stored. So storage databases can be used, while once the data is to be transferred or real time displayed, there Kafka shows its magic. So this is the producer. This is the Uber cab. And for example, we have 1 lakh operations or 100K operations per second. And the data transferred is the speed and the location. Now, this is the producer. It will go to the Apache Kafka server, and the server has these functionalities running these services. As we saw that Uber or Zomato has all these services running hand in hand. Services to calculate the fare, services to manage internal analytics, that how the driver is driving, how many harsh brakes did he apply, is the experience overall improving or declining, or what sort, maybe they use that to calculate their rating management system, and then some feed to show to the customer. All these services is managed by different logics in the application, and Kafka takes care of all these things. And this producer sends data to Apache Kafka server. Apache Kafka server uses this data to feed all these services, and once the optimum results are calculated, the data has now, it is to be stored somewhere, right? You used it to calculate, you displayed it to the customer, but now this data has to be thrown somewhere or like dumped somewhere. That has to be the database. Now you can do one bulk insert to the database. We just made all the operations, and inserted it to the database. So we did only one operation. Let me explain you. You did 100K operations with Apache Kafka, and then it is stored in the Apache Kafka server for a very short period of time. Now, when 100K database operations are accumulated, now you can bulk insert it to the database. So you used Apache Kafka for calculating all this stuff and real time displaying it to the customer. Real time streaming Apache Kafka was used. Once you had to store this stuff, then databases came into action. So producer, as we saw the Uber cabs, or any person or any entity who is generating the data, which is generating the data, is the producer. Apache Kafka has subdivided groups called topics. Now, what are topics? Logical partitioning of messages. Let me explain. Logical partitioning of messages, like we have in the context of a food delivery application, some updates will be from the restaurants and some will be the delivery partner updates. For example, a message that food is currently being cooked or we received your order will be from the restaurant, while your food is coming or arriving in the next 3 minutes, or your food has arrived on the doorstep, will be the delivery partner updates. So these messages will be categorized into different topics. For example, in Discord, also the same functionality is implemented. And then it once they are managed well and they are sorted, categorized, they are then displayed to the customer and then stored also. So partitions are there, and partitions have topics, and then we have consumers. Consumers, and the issue with Apache Kafka is that one customer can be mapped to one or more partitions. However, one customer will be left ideal here. Why? Let's understand. So, one customer can consume multiple partitions. One customer can consume multiple partitions. So, this consumer can fetch data from this partition as well as this partition. But one partition can serve only one consumer, right? So this is something which we need to take care of. And for example, we have four partitions here and we have five consumers. So one consumer will be mapped to one partition or multiple partition. So one customer ID one can fetch the can fetch the served data from zero, first, second, and the third partition as well. One or multiple. But one partition can serve data to only one customer. So it's like one to many, but many to one is not possible. That is the case. And since we have only four partitions, so it can serve maximum four consumers because one partition can serve only one consumer. And that is something we need to address. And how do we address that? Because here, if we see, one of the five consumers will remain idle. They will not have any data to fetch upon. And if consumer number one only fetches data from all the four partitions, then all the other consumers will remain idle, right? So to address this problem, we have some arrangement called consumer groups. So let's conclude today's learnings. Today we discussed what Apache Kafka is, what problem does it solve, why databases were insufficient in Singularity, and what Apache Kafka brings to the table, its high-level architecture, its working, functionality, and we discussed towards the end that there is an issue that one consumer can consume multiple partitions, but one partition can serve only one consumer. We have something to deal with that as well. What are those arrangements that are called consumer groups? And we'll be discussing that towards the next video. In subsequent videos, we'll also be doing a hands-on with integrating Apache Kafka in a Node.js application, discuss further functionality, a lot more to come. Other than that, thank you for having me. Keep learning, keep exploring, and I'll see you the next time.